Hello everyone. Welcome to the course of Internet of Things, in short IoT. In today's class, we are going to learn a new concept called location aware in the IoT patterns. Coming to the concept of location aware in the IoT patterns, we are going to integrate a GPS module in order to fetch the GPS coordinates from the satellite, and these particular GPS coordinates are given to the Arduino Uno, and with the help of the Wi-Fi shield, the Arduino Uno transmits the coordinates to the HTTP server using HTTP protocol time to time, and using web app, any user can fetch that particular coordinates of the GPS module of its current location. Now this is the example what we are going to take. So if you observe the block diagram, so the first section consists of a GPS module which communicates with the satellite and connected with the help of an Arduino Uno and Wi-Fi module or the Wi-Fi shield, and that particular data is going to the HTTP server, and through HTTP server the user can access the location with the web application or a web app. Coming to the learning objectives, we can read the GPS coordinates. So reading the GPS coordinates can be one of the objective, and publishing the same GPS coordinates to the server using HTTP protocol is one of the objective, and displaying those GPS coordinates in the web application or in the maps is one of the objective. So for this purpose, the hardware required is of course the GPS module. So here we are using Neo 6M GPS module, and this is integrated to the Arduino Uno or interfaced with the Arduino Uno with the help of connecting wires and an uh, breadboard for the interface. And for the Wi-Fi shield, we are going for an Wi-Fi shield for the internet connection for the Arduino Uno, and a basic power supply is provided to all of these. So coming to the software requirements, so in order to write the code for the Arduino Uno, we need to go for at least a basic version of Arduino IDE with version 1.6.4, and we need a PHP server to show the data of that particular server into the web application. So we need the PHP server to be installed, and we need a database where time to time all the GPS data will be stored in that particular database, and if necessary we need a text editor as well. And coming to the circuit diagram, so this is the GPS module Neo 6M. So this will be having generally 4 pins. One pin will be the VCC. So the 5 volts or 3.3 volts from the Arduino Uno can be connected to the VCC pin of GPS module, and one pin will be the uh, ground pin, which is connected or interfaced to the ground pin of the Arduino Uno, and the remaining 2 pins are the transmitting pin and receiving pin, where it goes again to the transmitting and receiving pin of the Arduino Uno. So this is a basic circuit diagram connection, and this is how it looks once we interface with that, and the Wi-Fi shield will be interfaced or integrated on top of the Arduino Uno. So this is the basic wiring diagram or the circuit diagram. And coming to the database table, MySQL, as you know, the database is a table which consists of rows and columns, and we will be creating some files related to the GPS, where we have taken like GPS underscore tracker underscore data, and we have columns, new client ID, last updated data, latitude, longitude, all these data will be stored in these particular folders. So as we need to code for the PHP, we will be creating a file like util-dbcon.php, where util is the utility, hyphen dbcon is nothing but the database connection. So in order to establish the database connection with the PHP, we are going to create this particular file, and we will be giving an saving library like a GPS tracker. Okay. So in order to receive and store the sensor data, every time we get a new data, it should get received and stored, right? So we will be creating one PHP file like update.php. Okay. So these are the main things, creating the files with respect to the database connection. And coming to the code of Arduino, we will be considering few things like external libraries, internet connectivity, reading GPS coordinates, and HTTP functions and standard functions. Okay, so let's see what are those. So coming to the external libraries, we have SPI.h, which is nothing but the serial peripheral interface with the with .h header file. And in order to connect or use the internet connection, we are going for an Wi-Fi.h wireless fidelity header file. And as we are using Neo 6M GPS module, it need a header file or an external library, which is nothing but called as tinygps.h. Okay. So tinygps.h is nothing but the header file of the GPS module, where GPS stands for Global Positioning System. Okay. And here we are trying to get the coordinates with respect to the serial monitor. So we will be using this software serial dot header files or the external files. Okay. Now in order to publish HTTP request, we need to get the command like make the command like get GPS tracker update. Each time that the data gets updated, suppose let us say the GPS module is in a car and is in moving state. Okay. So every time the coordinates changes, right? So every time the data gets changes or the data gets received, we will be having the get HTTP request through which the GPS tracker data gets updated each and every time. So this is the request data, okay, which will be printed on that particular client. Okay. Coming to the standard functions, we will be having void setup and void loop. And in void setup, we have serial communication where serial dot begin. For the GPS module, we will be considering 115200. Okay, that's the baud rate we'll be considering for the GPS data. And for software serial, we will be considering a normal baud rate like 9600 baud rate. And if you want to connect the Arduino to the internet, we'll be using a function like connect to internet function. And in the void loop, we need to continuously get the data of the GPS coordinates, right? So obviously we will be using going for a command like get GPS coordinates. Okay, so this is the command. So once everything connection is done, every coding is done and uploaded completely, this is how you can track the location in a live. Okay, so everybody might be aware of Google Maps, right? So if somebody says shares the location, you can clearly click on that and you can see the complete location or the route where you it can be directed. Okay, so same way, this experiment is also will be providing the same graphical user interface scenario in the PHP or an web app. Okay. So if you see the serial monitor of the Arduino, this is how it looks. You can see the connecting to the server's IP address, MAC address. So if you see the latitude and longitude, you can see the values of latitude and longitude, HTTP connection request, everything can be seen over here.